Here we have like an example of a blueprint for you, a swap demo. It's like a very simple blueprint where you can swap tokens. So you send token A, you send one token A, you receive one token B. The ratio is fixed. I did like a very simple example. There's more here I can show you, but here's for this presentation, I guess. It's simple enough and it covers what we need. And if you come here, here you set the blueprints to be accepted, to be valid into the testnet, into the Nano testnet, let's say. It's not like a testnet you're running local, but yeah. Here, you are adding it to the list of blueprints. Very simple. And now, after two very simple files, you have your blueprint. And after the blueprint, I'll go through it in a minute. You have the unit test for your blueprint. And I'm going to show you a bit of how it goes. So this blueprint here, see, it's like a class. You don't have to worry about the blockchain. You don't have to worry about reorgs. It's the blockchain's problem to decide the order that the transactions will be executed. You don't have to worry about this. You just have to worry about the behavior of your blueprint. So all your attributes must be declared at the top of your blueprint. So here we have like 5 attributes. Token A, which is the ID of a token, because we're going to do swap. So we're going to accept only token A, token B. Token B, which is the other one that we're going to do the swap. A multiplier for A, a multiplier for B. That's a way of doing ratio. It's not important here. We can do like 1A for 2 Bs, 1A for 3 Bs, or 1 for 1, 1A for 1 B. It's like fixed. It's like a simple example. You could require ATR tokens. You could charge deposits, charge fees. You could collect your fees. You could have administrator behavior here. It depends on what we need. Here is a very simple example. And here we have a counter of how many swaps have been successfully executed. We're going to run this. So you're going to see it in action. Here we have like the initialize method, which is public. And basically means that it's going to be executed by the blockchain. The first attribute is always a context. It makes like testing very easy. I'm going to show you. And then after that, you have like the attributes, token A, token B, multiplier. Here, just like any regular class, you just use it just like a regular class. It's not like, you don't have to worry about like a special thing. You don't have to use like a storage. Just develop the class. Here, there are some checks, very easy checks. Token A, token B cannot be equal. And if you want to fail a transaction, you just raise an exception. NEC fail, Nano Contract fail is like the classic way, but you can customize the exception. So here, at the end, you have like, you can customize, create your own exceptions. It's easy for testing, usually. So here, invalid tokens, because the initialize method requires like 2 actions, a deposit of token A and a deposit of token B. So there must be 2 actions, one for token A, one for token B, and both must be deposits. Only deposits allowed here. So that's a very simple thing. There's no like add liquidity method here, but it could have been here. It's just like we made like something very simple for here. And what does it mean to accept a transaction? If it runs up to the end and it ends, then accept it. Same thing for the method swap. Swap is very straightforward. Has a context with the list of actions, and that's it. There's no attribute. You just send X token A, Y token B, and it decides whether it accepts or not. So here, they force, you can only send token A, token B, nothing else. No token C, no ATR. Anything else is fail. Anything else fails. Then gets the actions, and it checks that must be like 1 deposit and 1 withdrawal. Then it checks if the ratio is valid. It uses like a private method. So is ratio valid is a private method because this one is marked as public, this one is not. If the ratio is invalid, it raises invalid ratio exception. Otherwise, it just execute the swap because the swap is part of the deposit and withdrawals. There's nothing to be done here. Just accept them. You could limit the amounts. You could do any kind of rules, custom rules that you need. But it sums one. It adds one, adds one here. It increases the counter so we can see that transactions have been executed. That's basically it. Very simple. Very straightforward. You just develop it just like you're coding Python. After that, you want to test it, of course. So it's very simple to test. So here is a method that creates one of these contracts. You just define the actions. So here, deposit token A, amount, deposit token B, amount. Create your context. I can give you more information later, but basically a list of actions. The transaction itself, here, the transaction is not used by the contract. So I can send a dummy transaction, it doesn't matter. The address, the caller doesn't matter. In liquidity pools, they do matter. Into bad system, they do matter. But here, they don't matter. So I sent a dummy address. I don't care. And the timestamp is the time of execution. So it's not important here. I just send now. It's okay. And then call public methods. And it's going to execute. And then you can assert and check if everything went right. Then I created another method to execute a swap, which basically creates the two actions, one with the deposit, one with the withdraw. So negatives are withdraw, positives are deposits. They create the context and they call the method. Very, very simple. After that, you can create your test. So initialize with 100 tokens and 1. So the ratio is 1. 1 token A for 1 token B, or 1 token B for 1 token A. That's it. So send a valid swap. Swap 20 token A. So you're sending 20 token A and you're getting 20 token B. That's fine. When you check the balance of the contract, it has 120 now because it got 20, and it has 80 because it was 20 was withdrawn, and it has swap counter 1 because there was like one swap executed, and the wallet got this 20. But here I'm not checking the wallet. We're gonna see in a minute. I'm gonna run it. If I send invalid ratio, so here is 1 to 2. 1 by 2, invalid ratio. If I send like 2 deposits, invalid actions. If you send like more than the contract has, insufficient funds. So balance is not enough. If you send like a wrong token, it says invalid tokens. So you can test and you can confirm that nothing has changed. That's how it's supposed to work. The transactions have failed, all of them, all of this. And then you can send a valid one. You are withdrawing 60 token A and depositing 60 token B. So it was 120, so now it's 60. And you deposited 60, 80 plus 60, 140. Very straightforward, and the counter increased to 2 because there's another one that was successfully executed. And you can just now I have to change the screens I'm sharing. Share screen. Let me share my terminal here. Here I have the full node, so I can just run the test. And see that it works. If I change the behavior, the test might fail. Very, very simple. And now I'm going to really interact with the transaction, just like a use case would do. So I'll run the full node here. I'll send all these command lines for you. You don't have to worry. So here I'm running my full node on my computer, right? It's not like connected to the network. It's running exclusively on my computer. On this tab, I'm going to run my wallet. It's running. Here, I'm going to run the transaction mining service. It's running. And the transaction mining service needs a miner. So I'm running like a very simple miner that doesn't use like a lot of CPU. It's very okay for what we need now. It's going to start in a second. Yeah, now it's mining and finding blocks. Here we have like a local blockchain running. Very simple, straightforward. So now that I have my development environment set up, I can move. Let me share another screen with you. I can move here to this Postman. We're going to share this with you too, okay? I don't know how to share Postman stuff, but I heard that it's possible, so I'll learn how to export it and share it with you. But the important part here is that let's run a wallet start. So now the wallet started. Can you see my screen? Just to double check.
Yeah, all good.
Okay. Here I can check my balance. I got the seeds of the pre-mined token. So I have like 1 million, and those here are the mined ones. So that's okay. I have no token A, so zero, but token A doesn't exist. This network is like from scratch. So let's create a token A. Here I'll use the API of the wallet to create a token. Very simple. This, create a token. Now a token A exists. Let me copy its ID. Let me put this here into the variable so we can use it later very easily. Now let's create token B. So here we can see like, this is token B, this is token A. Oh, sorry, you cannot see my terminal, right? Yeah, I can see in the terminal things happening. But yeah, here token B was created. So let me get its ID. Let me save the ID here, token B. Now that both tokens have been created, I have balance. I created like 100 token A, 1,000, sorry, 1,000. Remember, 00 here is just like comma, decimals. And same here. I have 100 token B, 1,000 token B, right? So and now I do have balance. So I can create that contract again. Now, to create the contracts, I'll just call create. It's very simple. I don't know if it's easy to read for you. I don't know how I can zoom here, but yeah, here is like the URL of the wallet desktop, the headless wallet. The blueprint code, an address of the caller, very simple. I'm depositing 100 token A, and I'm depositing 200 token B. Remember, I have to deposit something, and I have the arguments. Because of the initialize method there, it receives the ID of the token A, the ID of the token B, the multiplier of token A, the multiplier of token B. Actually, we can see this here. Let me duplicate this. And we have an API to get blueprints info. So /nano contract /blueprint. Now I can put here blueprint ID, and here the blueprint ID. I hope it's right. Yeah, it is. See, the initialize method has like these args: token A, token B, multiplier A, multiplier B, and no return. So here we have to create a contract. Let me do this. Token A, token B, multiplier is 1. So it's 1 to swap 1A for 1B and 1B for 1A. So let me run it. So it was successfully sent to the full node. It's going to be executed by the block. Let's find the ID. Here is the contract ID. So now we do have a contract. I can create as many as I want with different ratios. They are independent. Here, I just created one. Now that's created, I can get its history. There it is. There's just one transaction. I don't know if there's a way to see how big lists are here, but yeah, there's just one, which is the token creation, the contract creation. And we can read the state. So it has the token A that's the idea of token A. That's the idea of token B. It has 0 swaps. Nothing has been executed. It was just created. It has a balance of 100 token A and 200 token B. Very simple. We can call as well if you want, call the internal methods. And finally, we can go to execute method, and we can execute a swap. Let me rename it swap. Basically, we have to send the contract ID, the actions. So now that's an example. We are depositing 500, 300 token A, 500 token B. It's not 1 for 1, so it's going to fail if I'm going to do this. Let's fail later. Let's successful first. Let's execute it first. So same. So we are sending 300s to the contracts and getting 300s to the wallets. So let's see it happening, okay? No args, because the swap has no args, as we can see here. has only actions. So execute. It was sent to the network. So the transaction is, we can see the transaction here. That's all the information. And here we have the hash of the transaction, which is not really important right now. But if you go to the history and we query here, we're going to see the history. There we go. We have the one here. We're supposed to have two items here. Yeah. One is the token creation. Let's see. Yeah, that's a token creation. And next we have like the transaction itself, the one that we just created. Okay. I can follow the log here. There was no block yet. So if we query the state, it's going to be the same. It's just like swap counter 0, but a block will come up and we will execute. And if we go, let's take this opportunity to send another transaction with invalid values. So let's send like 500 and 300. So it's not one-to-one. So it's not going to be executed. It's going to fail. So let's send it to the network. It's sent. Okay. And now we can come here and check the history. But more importantly, we're going to see that it's not going to update the contract. Let's come here to the state of the contract. See, one was executed, just one. Now the contract received 300 token A, so a deposit was made, and a withdrawal of 300 was made here. So the contract received 300 and it sent 300 to another wallet. Which wallet? Our wallet. We can come here, token A, and check. Remember, it was like 1,000. We used 100 to create the contract, so it's 900. So it sent 300 or 3 to the contract, 300 units. So it was supposed to be 90,000 here, but it sent 300. Same thing to B. It was supposed to be, when we created the contract, we created with, 200B. So it's going to be 800, but he received 300. So it's 880 and 300 because it received. So this wallet received the tokens that came from the contract. It was a withdrawal accepted. And if you go to the second transaction that we sent, the one that failed, see, it was successful because the network accepted it. But if we get this information from the full node, we are going to see that, let me close the things here. It's voided. And this is the code that means that the transaction failed execution. And if you run in your terminal, you can check that the failure was because the ratio was wrong. We sent like, I don't remember now, we sent 300 token A and 500 token B, so they're supposed to be the same for this contract specifically. We can create other contracts, but here you have like everything happening live in your computer. You can automate all these things if you want. And let me very quickly stop sharing here and share my terminal back so you can see that you can follow on your terminal everything happening live. So here we have like the last transaction that we sent. It's here. See, it's a nano transaction. Here's another transaction. So you can see everything happening. It was a push to TX that the wallet used. And here's the transaction. So you can see everything happening on your log. And here we have like the wallet log, the mining service log, and okay, that's what matters.